Hello friends, welcome to Study with Dr. Dafda. I am Dr. Dafda, and in this video we will see the story of India's inspiring journey to the moon. From its humble start to its proud achievements, the Chandrayaan mission shows the strength of India's science and the courage to dream big in space exploration. Come, let us together re-experience this wonderful journey. Friends, this slide shows the journey of India's Chandrayaan mission over the years. In 2008, Chandrayaan 1 was launched. It was India's very first mission to the moon, and it made the historic discovery of water molecules on the lunar surface. This put India on the world map of space exploration. In 2019, we had Chandrayaan 2. The orbiter worked wonderfully and gave us excellent data. Though the lander could not make a successful landing, it still provided very useful scientific information. And finally, in 2023, Chandrayaan 3 marked a proud moment for India. It achieved a successful soft landing near the moon's south pole, making India the fourth country in the world after US, Russia and China to achieve a soft landing on the moon. Furthermore, India is the first and so far the only country to achieve a soft landing in this specific South Pole region, which is a key target for future lunar missions due to the potential presence of frozen water. And it was truly a milestone for our nation. Let us now go into the details of each of these missions one by one. Chandrayaan 1 was India's very first mission to the moon. It was launched on October 22, 2008 from Sriharikota, our spaceport in Andhra Pradesh. For the first time, an Indian spacecraft went and orbited the moon at about 100 kilometers above its surface. The main aim of this mission was to study moon in detail, that is its surface, its minerals, its chemicals compositions and also its geological features. What makes Chandrayaan 1 very special is that it carried 11 scientific instruments, not only from India but also from other countries like USA, UK, Germany, Sweden and Bulgaria. This shows India's spirit of cooperation and leadership in space science. The mission was highly successful. After completing its main objectives, ISRO raised the spacecraft's orbit to 200 kilometers in May 2009. The satellite went around the moon more than 3,400 times, and finally, in August 2009, after giving us so much valuable information, contact with the spacecraft was lost. But by then, Chandrayaan 1 had already made India proud and had achieved all its major goals. Let us now understand how Chandrayaan 1 reached the moon. Chandrayaan 1 was launched on 22nd October 2008 by PSLV C-11, and instead of a direct path, ISRO used a clever method called orbit raising. The spacecraft's engine was fired in steps called the Earth Burns, that is EBN 1 to 5, to slowly stretch its orbit further away from the Earth until it was captured by the moon's gravity. Once near the moon, a second set of maneuvers that control satellite motion called the moon burns, that is MBN 1 to 4, were done. And these slowed down the spacecraft so that it could settle into the orbit around the moon. It reached the moon as shown in this video. And finally, on 12th November, it was placed in its working orbit of 100 kilometers around the moon. See, this step-by-step approach saves fuel, reduces cost and allows use of smaller rockets, giving better control compared to a direct flight. On 14th November, the Moon Impact Probe was released carrying the Indian flag and impacted near the South Pole. It confirmed the presence of water on the moon, which was one of the most historic discoveries. After this, the orbiter continued mapping and studying the moon with 11 scientific instruments. Now let us look at some important facts about Chandrayaan 1. This mission was mainly for remote sensing and planetary science. That means it was designed to study the moon from above by using powerful instruments. The spacecraft weighed about 1380 kilograms at the time of launch, and it generated 700 watts of power for its systems. It was stabilized using a very advanced 3-axis stabilization control system, and this system used many sensors like star sensors, sun sensors, gyroscopes and thrusters to keep the spacecraft steady and pointing in the right direction. India also developed its own scientific instruments for this mission. There was the terrain mapping camera TMC, which helped create 3D maps of the moon's surface. The terrain mapping stereo camera on Chandrayaan 1 was designed to make a 3D atlas of the moon by mapping both the near and far sides with very high resolution to understand moon's surface and gravity and evolution. The camera could capture black and white images at about 5-meter resolution and cover 20 km wide areas even under different lighting conditions. TMC used advanced sensors, optics and electronics, weighed only about 7 kg and sent data at a high speed of 50 Mbps. This image shows a small floor crater on the moon captured by TMC, and this image shows overlapping crater on moon. Next, the hyperspectral imager was used to study the minerals. The hyperspectral imager or HYSI on Chandrayaan 1 was designed to study the minerals on the moon's surface using spectroscopic data. It could map the surface in 32 bands of visible and near infrared region, helping scientists understand the mineral composition, especially in deep craters and peaks that expose material from the moon's interior. The hyperspectral imager had a resolution of 80 meters. It covered 20 kilometers at a time and used a special wedge filter to make the instrument compact and lightweight. Developed by the ISRO, the payload weighed only 4 kg and played an important role in revealing the moon's mineral diversity. This image, captured using hyperspectral imager, shows a relay, that is a narrow channel on the moon's surface at different bends. And this image shows a small floor crater that is assigned different color bands for making it more informative. Next was the lunar laser ranging instrument, which helped in studying the moon's shape and size. The lunar laser ranging instrument on Chandrayaan 1 was designed to measure the height of the moon's surface and prepare a detailed topographic map. By sending infrared laser pulses and measuring their reflection, it helped in studying the moon's shape, surface features, gravity field, and even provided clues about its internal structure. This data, combined with other instruments like the terrain mapping camera and hyperspectral imager, improved our understanding of the moon's crust, basins, and geological history. The LLRI was built by ISRO. It weighed less than 10 kg and could collect 10 measurements every second, both in day and night conditions. The next instrument was High Energy X-ray Spectrometer or HEX, which was used to detect different minerals present on the moon. The High Energy X-ray Spectrometer on Chandrayaan 1 was the first experiment to study a planetary surface in the hard X-ray region, that is 30 to 250 kilo-electron volt with high resolution. It measured radioactive elements like uranium, thorium, lead and radon on the moon's surface, helping scientists understand the moon's chemical makeup. HEX also studied how radioactive decay products such as radon might transport volatiles like water to the polar regions. With a resolution of about 40 kilometers, a detector area of 144 centimeters square and weighing 16 kg, HEX provided valuable data about the moon's terrains and their composition. Okay. And the most famous instrument was the Moon Impact Probe or MIP. This small probe was released from Chandrayaan 1 and it landed on Moon's surface, and it was this probe which confirmed the presence of water molecules on the Moon. And this was a historic discovery which put India's name in golden letters in the history of space exploration. The Moon Impact Probe developed by ISRO was a small 29 kg probe released from Chandrayaan 1 on 14th November 2008. It carried instruments like a radar altimeter, video camera, and mass spectrometer to study the Moon's surface and thin atmosphere. This probe successfully impacted near the lunar south pole, carrying an Indian flag, making India the fourth nation to place its flag on the Moon. During its descent, MIP made the historic discovery of water on the Moon, even before NASA confirmed it. It also tested key technologies needed for India's future soft landing missions. This left image shows how the Moon's surface reflects light in infrared, highlighting its brightness. And the right image is also the same image, but the area in blue is marking where water and hydroxyl minerals are present. Chandrayaan 2 was India's second big step towards the Moon after the success of Chandrayaan 1. What makes it very special is that all its parts, the orbiter, the Vikram lander, and the Pragyan rover, were developed here in India by ISRO scientists. The mission's purpose was to map the Moon, study its rock and minerals, and to locate water on the lunar surface. It was launched on 22nd July 2019 from Satish Dhawan Space Center, Sriharikota, using India's most powerful rocket, GSLV Mk3. While the Vikram lander faced difficulties, the orbiter is still working perfectly and is continuously sending us new scientific information about the Moon. Now let us look at the journey and challenges of this mission. The Vikram lander was scheduled to land softly on 6th September 2019 near the Moon's south pole, and it was a place not explored before. Unfortunately, in the last moments of its descent, due to software glitch, it lost contact and crash landed. This figure shows the impact site of Vikram lander on the Moon on 6th September 2019, along with the scattered debris and the soil distribution marks, confirming that the lander had a hard landing instead of soft touchdown. Even though the lander did not succeed, the orbiter continues to function well and is providing us with high quality data. Initially, this project was supposed to be in collaboration with Russia, but when they could not provide the lander, India took the bold step of developing it independently. This mission taught us valuable lessons, and with that knowledge, ISRO prepared for Chandrayaan 3, which finally achieved a historic soft landing in 2023. Chandrayaan 2 gave three very important findings. First, its Chase 2 instrument studied the Moon's very thin atmosphere. It detected argon-40 gas not only near the equator, but also at higher latitudes. This shows that gases on the Moon move differently depending on the time of day and location, and are linked to special regions like the creep terrain and the South Pole Aitken Basin. Second, the terrain mapping camera TMC-2 discovered a lobate scrap, which is a small fault line created when the Moon's surface cracked due to internal forces. The figure here shows the scrap marked in yellow and profiles P1 to P4 that measure changes in surface height. These profiles prove that the scrap is geologically young, meaning the Moon is still slowly active and not completely dead. This figure shows how a lobate scrap is formed when the Moon's surface cracks and pushes up like a small curved hill. The right image is an actual photograph of such a lobate scrap seen on Moon's surface. Finally, the X-ray solar monitor, that is XSM, studied the Sun from lunar orbit. It measured small solar flares and the changing amounts of important elements like magnesium and silicon. This is the first time such precise measurements have been made, giving scientists new knowledge about how the Sun behaves during even small flares. So overall, Chandrayaan 2 helped us learn about the Moon's atmosphere, its ongoing surface activity, and even about the Sun. And not only this, the Chandrayaan 2 orbiter, circling the Moon since 2019, has guided many missions and spotted important surface features, including the Apollo 11 lander that carried Neil Armstrong to the Moon in 1969. Friends, Chandrayaan 3 is India's proud follow-up mission after Chandrayaan 2. The main aim of this mission was to prove that we can safely land on the Moon and also operate a rover there. The spacecraft had three important parts. First, the propulsion module. This carried the lander and the rover to the moon's orbit at about 100 km distance. Second, the lander named Vikram, which actually landed on the moon's surface. And third, the rover named Pragyan, which came out from the lander and moved and studied the lunar soil. The rocket was LVM-3 from Sriharikota. Another small but important instrument called SHAPE, which is an abbreviation for Spectropolarimetry of Habitable Planet Earth, was also added, which studied the Earth from the moon's orbit. This is how the soft landing took place. This is a very big achievement for India. No other country in the world had landed on the moon's south pole before. The lander named Vikram safely touched the moon, and from it came out the rover named Pragyan. These two worked together like a team. They studied the soil, rocks, and surface of the moon to find new information. One special thing about Chandrayaan 3 is that it was done in a very less cost compared to other countries. This showed that India can do smart science and space research with less money. The whole world praised India for this success. And this is an actual photograph of the Vikram lander taken by Pragyan rover. This part tells us about what happened after Chandrayaan 3's successful landing. After the lander Vikram made the soft landing at the South Pole, the rover came out and started moving on the lunar ground. Pragyan worked for about 10 days collecting important data. The rover was designed to survive very high and low temperatures from 70 degrees Celsius to minus 10 degrees Celsius, and it could even decide how to move safely on the rough and dusty surface. Using its scientific instrument, the Alpha Particle X-ray Spectrometer (APXS), Pragyan studied the soil and found minerals. It took 23 readings in total. The scientists also found signs of a giant meteorite crash that happened 4 billion years ago. This created the South Pole Aitken Basin, which is around 2,500 kilometers wide, and it is one of the largest craters in the solar system. They detected magnesium, which most likely came from deep inside the moon during that big impact. These results are very important because they take us closer to finding water ice on the moon's south pole. If water ice is confirmed, it can help in building human bases on the moon in the future. The Pragyan rover moved more than 100 meters, which is a big achievement as the South Pole is full of craters. It avoided them safely. Data showed that just below the surface, temperature changes very fast, proving that lunar soil is a good insulator that can be useful for building future moon habitats. ISRO also confirmed sulfur on the moon's surface, which is important for understanding moon's history and could even help farming in future colonies. Vikram also detected vibrations, which may be a moonquake or maybe a meteorite hit, and ISRO measured lunar plasma, which is very thin, which means that radio communication on the moon works very well. Just before being put to sleep, Vikram lander carried out a hop experiment. It fired its engines, lifted slightly from the moon, and landed a few centimeters away. This simple test is very important because it shows that the engines can restart even on the lunar surface. In the future, this could help India bring moon samples back to Earth or even send astronauts to the moon. This small hop could become a giant leap for India's future space dreams. Just like Chandrayaan 1 and Chandrayaan 2, Chandrayaan 3 also carried many scientific instruments with advanced technologies. India named the moon landing places as Shiv Shakti Point and the Tiranga Point to honor our scientific spirit, resilience, and to inspire future generations. And through future missions like Chandrayaan 4 and Chandrayaan 5, India is preparing for bigger goals like sending humans to the moon by 2040. So that is all for this video class. I hope you learned something useful and got some inspiration from it. Always remember, every small step in learning takes you closer to big success. Thank you very much.